Oak Ridge National Laboratory is an American multiprogram science and technology national laboratory managed for the United States Department of Energy by UT-Battelle.ORNL is the largest science and energy national laboratory in the Department of Energy system by acreage and by annual budget. ORNL is located in Oak Ridge, Tennessee, near Knoxville. ORNL's scientific programs focus on materials, neutron science, energy, high-performance computing, systems biology and national security. ORNL partners with the state of Tennessee, universities and industries to solve challenges in energy, advanced materials, manufacturing, security and physics. The laboratory is home to several of the world's top supercomputers, including the world's second most powerful supercomputer ranked by the TOP 500, Titan, and is a leading neutron science and nuclear energy research facility that includes the spallation neutron source and high-flux isotope reactor. ORNL hosts the Center for Nanophase Material Sciences, the Bioenergy Science Center, and the Consortium for Advanced Simulation of Light-Water Reactors. Overview. Oak Ridge National Laboratory is managed by UT-Battelle, a limited liability partnership between the University of Tennessee and the Battle Memorial Institute, formed in 2000 for that purpose. The annual budget is $1.65 billion. 80% of which is from the Department of Energy, the remainder is from various sources paying for use of the facilities. As of 2012 there are 4,400 staff working at ORNL, 1,600 of which are directly conducting research, and an additional 3,000 guest researchers annually. There are 5 campuses on the Department of Energy's Oak Ridge Reservation: the National Laboratory, the Y-12 National Security Complex, the East Tennessee Technology Park, the Oak Ridge Institute for Science and Education, and the developing Oak Ridge Science and Technology Park. Although the 4 other facilities are unrelated to the National Laboratory, the total area of the reservation 150 square kilometers, of which the lab takes up 18 square kilometers. History. The town of Oak Ridge was established by the Army Corps of Engineers as part of the Clinton Engineer Works in 1942 on isolated farmland as part of the Manhattan Project. In 1943, construction of the Clinton Laboratories was completed, later renamed to Oak Ridge National Laboratory. The site was chosen for the X-10 graphite reactor, used to show that plutonium can be extracted from enriched uranium. Enrico Fermi and his colleagues developed the world's second self-sustaining nuclear reactor after Fermi's previous experiment, Chicago Pile 1. The X-10 was the first designed for continuous operation. After the end of World War II, the demand for weapons-grade plutonium fell and the reactor and the laboratory's 1,000 employees were no longer involved in nuclear weapons. Instead, it was used for scientific research. In 1946, the first medical isotopes were produced in the X-10 reactor. By 1950, almost 20,000 samples had been shipped to various hospitals. As the demand for military science had fallen dramatically, the future of the lab was uncertain. Management of the lab was contracted by the U.S. government to Monsanto. However, they withdrew in 1947. The University of Chicago assumed responsibility but withdrew shortly after, until in December 1947 Union Carbide and Carbon Co., which already operated 2 other facilities at Oak Ridge, took control of the laboratory and Alvin Weinberg was named Director of Research ORNL, and in 1955 Director of the laboratory. In 1950 the Oak Ridge School of Reactor Technology was established with 2 courses in reactor operation and safety. Almost 1,000 students graduated. Much of the research performed at ORNL in the 1950s was relating to nuclear reactors as a form of energy production both for propulsion and electricity. More reactors were built in the 1950s than the rest of the ORNL's history combined. Though experiment X-10 was the first light water reactor, it remains the most common type of nuclear reactor as of 2012. The U.S. military funded much of the reactor development, leading to the nuclear-powered submarines and ships of the U.S. Navy. The U.S. Army contracted portable nuclear reactors in 1953 for heat and electricity generation in remote military bases. The reactors were designed at ORNL, produced by American Locomotive Company and used in Greenland, the Panama Canal Zone and Antarctica. The United States Air Force also contributed funding to 3 reactors, the lab's first computers, and its first particle accelerators. ORNL designed and tested a nuclear-powered aircraft in 1954 as a proof of concept for a proposed USAF fleet of long-range bombers, although it never flew. The provision of radionuclides by X-10 for medicine grew steadily in the 1950s with more isotopes available. ORNL was the only Western source of Californium-252. ORNL scientists lowered the immune systems of mice and performed the world's first successful bone marrow transplant. In the early 1960s there was a large push at ORNL to develop nuclear-powered desalination plants where deserts met the sea to provide water. The project, called Water for Peace, was backed by John F. Kennedy and Lyndon B. Johnson and presented at a 1964 United Nations conference, but increases in the cost of construction and public confidence in nuclear power falling caused the plan to fail. The health physics research reactor, built in 1962, was used for radiation exposure experiments, leading to more accurate dosage limits, dosimeters, and improved radiation shielding. In 1964, the Molten Salt reactor experiment began with the construction of the reactor. It was operated from 1966 until 1969 and proved the viability of molten salt reactors while also producing fuel for other reactors as a byproduct of its own reaction. The high-flux isotope reactor, built in 1965 with the highest neutron flux of any reactor at the time. It improved upon the work of the X-10 reactor, producing more medical isotopes as well as allowing higher fidelity of materials research. Researchers in the biology division studied the effects of chemicals on mice, including petrol fumes, pesticides, and tobacco. In the late 1960s, cuts in funding led to plans for another particle accelerator to be cancelled, and the United States Atomic Energy Commission cut the breeder reactor program by 2/3, leading to a downsizing in staff from 5,000 to 3,800. In the 1970s, the prospect of fusion power was strongly considered, sparking research at ORNL. A tokamak called ORMAK, made operational in 1971, was the first tokamak to achieve a plasma temperature of 20 million Kelvin. After the success of the fusion experiments, it was enlarged and renamed ORMAK-2 in 1973. However, the experiments ultimately failed to lead to fusion power plants. The U.S. Atomic Energy Commission required improved safety standards in the early 1970s for nuclear reactors, so ORNL staff wrote almost 100 requirements covering many factors, including fuel transport and earthquake resistance. In 1972, the AEC held a series of public hearings where emergency cooling requirements were highlighted and the safety requirements became more stringent. ORNL was involved in analyzing the damage to the core of the 3 Mile Island nuclear generating station after the accident in 1979. Also in 1972, Peter Mazur, a biologist at ORNL, froze with liquid nitrogen, thawed and implanted mouse embryos in a surrogate mother. The mouse pups were born healthy. The technique is popular in the livestock industry, as it allows the embryos of valuable cattle to be transported easily, and a prize cow can have multiple eggs extracted and thus through in vitro fertilization have many more offspring than would naturally be possible. In 1974, Alvin Weinberg, director of the lab for 19 years, was replaced by Hermann Postma, a fusion scientist. In 1977, construction began for 6-meter superconducting electromagnets intended to control fusion reactions. The project was an international effort. 3 electromagnets were produced in the US, 1 in Japan, 1 in Switzerland and the final by remaining European states, and experimentation continued into the 1980s. The 1980s brought more changes to ORNL. A focus on efficiency became paramount. An accelerated climate simulation chamber was built that applied varying weather conditions to insulation to test its efficacy and durability faster than real-time. Materials research into heat-resistant ceramics for use in truck and high-tech car engines was performed, building upon the materials research that began in the nuclear reactors of the 1950s. In 1987, the High-Temperature Materials Laboratory was established, where ORNL and industry researchers cooperated on ceramic and alloy projects. The materials research budget at ORNL doubled after initial uncertainty regarding Reagan's economic policy of less government expenditure. In 1981, the Holyfield Heavy Ion Research Facility, a 25 MV particle accelerator, was opened at ORNL. At the time, Holyfield had the widest range of ion species and was twice as powerful as other accelerators, attracting hundreds of guest researchers each year. The Department of Energy was concerned with the pollution surrounding ORNL and it began cleanup efforts. Burial trenches and leaking pipes had contaminated the groundwater beneath the lab, and radiation tanks were sitting idle, full of waste. Estimates of the total cost of cleanup were into the hundreds of millions of US dollars. The 5 older reactors were subjected to safety reviews in 1987, ordered to be deactivated until the reviews were complete. By 1989, when the high-flux isotope reactor was restarted, the U.S. supply of certain medical isotopes was depleted. In 1989, the former executive officer of the American Association for the Advancement of Science, Alvin Travell Peace, became director of ORNL. He remained in the role until 2000. In 1992, a whistleblower, Charles Varnador, filed complaints against ORNL, alleging safety violations and retaliation by his superiors. While an administrative law judge ruled in Varnador's favor, the Secretary of Labor, Robert Reich, overturned that ruling. However, Varnador's case saw prime contractor Martin Marietta cited for safety violations, and ultimately led to additional whistleblower protection within DOE.